Alright, so first of all, as you said, my name is Dylan Constantinople, and I was thinking about this theme, taking things apart. We were going to talk about fixing things, and I realized I didn't start with fixing things. I started more than 28 years ago with taking things apart. And it started, I think, with a telephone. I think I took my parents' telephone apart. And I didn't really care about putting sides together. It turns out when you spend 28 years doing something, which some of you may not be to that point yet, or most of you, there are a lot of aspects that you end up fleshing out in that theme. There are design aspects of taking things apart. There are mechanical things, electrical things. So this is just audio and sort of design and sort of non-technical or slightly technical aspects of why you might want to take things apart. I'm not taking this apart, but the theme, the reason I'm going to, as you go through this presentation, you'll see pictures of architecture and landscaping and gardens that I've experienced while traveling. And the issue is, when you see the inside of electronics, you shouldn't just be thinking about your engineering classes or about very technical things. It should be speaking to you in other ways, from color to how the lines or the curves of the instrument were built. I mean, a lot of things have been industrial design to given components, and a lot of circuits have an elegance similar to art. So this was in a shrine outside Utsunomiya that I went to. It was awesome.
Was that Japan?
Yeah, in Japan. I thought about, first, the common audio thing you guys might be familiar with, the Technics turntable. Technics, if you're not familiar with DJ turntable, building a direct dive DJ turntable is a really big deal. This built two genres of music, sort of. I mean, basically, techno and hip hop are all about playing records and scratching and lots of things related to, now, arguably sampling also, but this was an early type of sampling. So what influenced this design, or what's in this design? How did these Japanese guys come up with a turntable? This guy, there's a normal picture of a Technics turntable. So there's the motor and the controller. This is a cost-reduced version of something they did earlier in the 70s, because they were basically, Panasonic was the first company to do a direct drive turntable. So by this point, they had miniaturized everything. So these are all Technics custom chips, and then something they bought from Mitsubishi. And then the actual direct drive motor, the coil system, and then the magnet sits on the bottom of the platter. So this has already gone through several design iterations to get to the point where it was this cheap and this easy to build. I think the first turntables were at least thousands back in the 70s. And they also made a drive for record lathes for cutting records that was direct drive, and that was even more expensive. And you can actually get the schematics online. And it's kind of a nice service schematic. You can see if you had a problem with your Techniques, they actually give you wave shapes of different pins on the chip and other chips. And so you could really develop at least some understanding. They don't tell you a ton about the custom chip, but parts of the service manual describe more about how it works. So you could buy Techniques, buy the manual, or could download it online for free, and kind of figure out how does the direct drive turntable work, and why is it interesting and elegant. I mean, obviously they spent serious money developing this custom chip so that they could build cheap direct drive turntables. So that's kind of an interesting thing. This was another picture of a shrine. This is in Kyoto, but just sort of, maybe the Imperial Palaces? I don't remember, but it was amazing. Big rocks. You can see the people are the size of the rocks. So, okay, this is about microphones, mainly Neumann microphones. So this is a U47, sort of a famous vacuum tube microphone. Various fairly well-known people, Frank Sinatra. Bob Dylan's actually playing in front of an M49 there, which is a similar microphone, but a little bit different. And then, is that George Harrison and John Lennon? There's a U47, and here's the inside. They came out around just after World War II, and the Neumann company in Germany asked Telefunken, which is the company that made this vacuum tube, to make a custom tube that would be low noise. So it's a low noise custom tube just for microphones, and it's shock mounted in foam and with rubber supports, and then custom transformer, custom caps, actually there's a transformer. Very fancy, typical German construction, nickel plating, expensive mechanical work, lots of shock mounting. But it was a big deal. It was the highest performance early vacuum tube microphone built. And it really early, like
So
51, 49.
how does that compare to now?
People spend $12,000 for this or more for this microphone to still use it. I mean,
So it's still some of the best.
oh yeah, no, I mean, there's a studio in Nashville called Blackbird Studio. It's run by John and Martina McBride, and they have hundreds of tube mics from the 50s.
Didn't you sell them a couple?
Yeah, but yeah, the main thing is studios all over the world still use these. This is the reference. Partly because, as you see, these guys made your favorite recordings with those mics. And so now it's the sound of the mic is, it's not just that the mic is high performance, they're nice modern high performance mics. They showed us it was high performance and helped define the sound that you love on your recordings. So it's an influential design, and it's a beautiful design. The curves, the nickel plating, the sort of overcomplicated care with which they build everything with Neumann. Custom connectors, really, really fancy. And then this is a schematic just of the microphone itself. This is the condenser diaphragm. It's basically a variable capacitor. And tube, it's a pentode, transformer, and the output connector, and then somewhere else there's a power supply. This is redrawn, but they claim 55. I'm pretty sure there's versions earlier than 55. So this is which one is this? Golden Palace. It's another Kyoto garden and building, and that's all gilded gold. It's kind of ridiculous. They reapply the gold foil every year if they need to. And it didn't matter where you stood. All the photos turn out like this. It's just ridiculous.
So it's not like a temple, you will and pray, or is it just kind of there?
I don't know if you can have, I think you can have a tea ceremony there if you're of a specific religion, but I don't remember how they did it. Alright, so another Beatles related thing. There's Paul McCartney sitting on top of, or standing next to one. This is a Swiss tape recorder from the 60s, 1963 or 4. It's a Studer J37. It's a 4-track 1-inch tape machine. Sgt. Pepper, all the layering of tracks on Sgt. Pepper, Sgt. Parker's Only Hearts Club Band, is using this machine to layer tracks. Pretty famous machine, and it's gorgeous. If you look at the inside, there's like 52 vacuum tubes, and really ridiculously nice motors and fuses, and every part of it is super overbuilt and easy to take apart and elegant. And unlike the Germans, the Swiss tend to be complicated, but everything works. Germans are just complicated, usually. This is more like a watch, only really big.
So how much is that now?
Typically they go for about 15 or 20 grand if you can find one. I have a 2-track one, but I don't have a 4-track. The 4-track's the expensive one because Paul bought a bunch of them. And there's a schematic for part of it, so more complex. But basically the vacuum tube version with a few nice tricks of what Professor Rose would teach us in circuit theory class is about tape, playback amps, and recordings. This is a playback amp. And sometime we can have a separate seminar just on tape machines if you want. But, or we can even do a demo sometime once I finish fixing one. But just really beautiful parts. I'll take some pictures later of the inside of one of these. The wiring's really careful. Everything's been designed out. They must have spent time drawing each module and deciding where can I put this cap to make it look good next to that part, and how can I get everything to fit with the parts being rectangular layout. Really nice. There's the Golden Gate Bridge. That was from an AES trip actually to San Francisco. It was a nice trip. So this is the American version of that tape machine. This is a 3-track Ampex. Almost all the recordings of the 50s and 60s in the US would have been put on one of these. Eventually they went to 8 tracks, but this is the earlier stuff like Sinatra and all that. It's 3-track. And Mamas and the Papas and various 60s things you may have heard.
So how does it compare to that Swiss one made? Is it?
So Americans build differently. You can see this is all stamped metal. The mechanicals are nice, but if you look at here, also nice. This is sort of American military style construction, so like Jones plugs and circular Amphenol plugs, but the style's different. If I had taken pictures of the inside, not as organized, maybe a bit more optimized performance actually. But the difference in an American machine is usually you can't take it apart as easily. Swiss stuff is designed to be ripped apart quickly. Everything fits together with screws. All the screws are the same type of size. This will use different types of fasteners. They didn't really care. They use roll pins, which you have to pound out or press out. So it's much harder to fix these in some ways. But the technical performance is very high.
But the performance is still
Very good.
The same or better than the...
Same, at least. I mean, this other machine was newer. This is 63, and this is maybe 50s, early 50s. Tape machines were designed in Germany during World War II, before World War II. And then GIs sort of grabbed them and took them back to America. So that's how they developed tape recorders. That's the bottom of the tape machine. So there's 3 motors and 2 brakes and a flywheel. And I'll demo a tape machine at another time. They're interesting. They're hard to fix because of all the mechanical stuff. And the performance you're shooting for with a tape machine is pretty tough to meet. And then there's the schematic. All the schematics are drawn differently between countries slightly. But similar. Usually Americans had more tricks technically. We had really good engineers for some of the stuff. And then sometimes we had lousy circuits. There were a few circuits with marginal stability or bad noise problems. This one was pretty good. Nice, this is the Baha'i shrine in Israel. It's pretty weird. It was interesting though. So that's Haifa out in the distance, the Mediterranean. So this is the Nagra. This is a Swiss, more modern transistorized tape machine. It's a single channel. It was for film. Just about every 60s, 70s film might have had some audio recorded on a Nagra. Tiny and portable, maybe the size of this oscilloscope, or a foot and a half wide or less. The idea is you carry it like a large man purse. But really beautiful design. I mean, they spend a ton of money on all these beautiful stainless fittings and aluminum and really precisely machining everything and trying to get everything to fit in this box. You can see the meter's super complicated for just being a meter. It's balanced so that if you're upside down or on its side, the movement's still balanced and accurate. And the schematic is simple, because they didn't have a lot of room. So anywhere where they could drop a transistor, they dropped a transistor. So lots of single-ended everywhere.
What year was that?
Early 60s, I'm not quite sure when. It's pretty early actually, like 65 maybe, 64, 65. So not much later, but single channel. It's a mono tape machine. That's the Western Wall in Jerusalem. So that was more big rocks, I guess. We got into test equipment. This is a pretty famous piece of test equipment. This is actually a later one, and I have one like this because these are common. But the original 200-day audio oscillator it's a Wien-Bridge oscillator, which Professor Wirsman teaches about in his class. But the main thing is Hewlett and Packard launched their company out of the garage in California with this product. It was used extensively on Fantasia, because Fantasia had like a 40-channel mixing desk, and they had to figure out how to get all the channels and equalizations to match, and how to set up movie theaters with a system called Fantasound, which was a multi-channel sound system that they launched with Fantasia. So they bought hundreds of these audio oscillators to test movie theaters and sound equipment and recording equipment, and that was sort of the launch of multi-channel theater sound and soundtracks and of Hewlett Packard. So when somebody says audio is not important for industry, Hewlett-Packard was launched by audio. So, and this is a really classic design for a lot of reasons. But there's the inside. Sort of primitive. This was early HP, and it's built a little bit more like a radio and a little bit less like a precision instrument. But they caught up later. But that said, they used oil caps, and usually the oil caps are still good. You can see electrolytics there though, just like in your tube amps. And there's the schematic. And the cool thing about HP is there's the circuit description. Unlike the other stuff, if you're trying to learn how circuits work and you're not quite sure, Hewlett-Packard told you how they think it works. You can start learning how to do things with tube circuits with, and there's more articles. I mean, he had to do his dissertation on resistance to an oscillator and stability. This is a nice initial introduction. And all of the 1950s and 60s, and some of the 70s Hewlett-Packard equipment gives you a long circuit description, telling you how the whole circuit works. This is a cathedral next to, or a church next to the Mount of Olives. I don't remember what it was. In Jerusalem, in Israel. All right, so these are the last piece of equipment. These are all Tektronix vacuum tube scopes. And the thing on the desk in the front of the room is a Tektronix vacuum tube scope. Tektronix at this time probably did the most integrated design of mechanical, compact packaging of high performance vacuum tube electronics. I mean, these were amazing scopes. Bandwidths up to 100 megahertz, or at least 85 megahertz. Really stressing pushing the boundary of what you could do with vacuum tubes in a scope. And sensitivities in the range of 50 or 100 microvolts per division. Numbers better than most modern solid-state scopes, digital scopes, just because nobody cares about measuring small noise or some of the other things that they used to measure commonly. And there's the inside one. This is probably part of the distributed amp for the vertical suite, but it's hard to tell. But then voltage regulator tubes and caps, probably a voltage a reference to, or just a small triode. But really beautiful. I mean, if you can imagine, you saw the earlier packaging. This was a lot more mechanical work. Trying to fit all these electronics. You know, the tubes are at different angles. There's wires everywhere. The packaging is really compact and neat. They built these custom ceramic strips to mount parts on, and that was featured only Tektronix instruments at the time. So the performance they were trying to get out of the instrument dictated this, but you end up with a really elegant instrument. And again, even better than HP, they give diagrams mixed in with the circuit description that give you wave shapes and voltages. So if you want to understand a circuit, you can actually step through everything, both using a scope to look at nodes of the circuit, measuring voltages with a voltmeter, and then they write up really nice write-ups of how all the circuits work. So really, really cool for learning pretty advanced circuit theory. Not circuit theory, but applications of circuit theory. And that's the Dome of the Rock in Jerusalem again. Labs you might do this work in. This was my shop lab. This was pretty luxurious, and I'm still trying to replicate it in my house. But parts bins, power supplies, test equipment, audio oscillators, etc.
Where was this?
That was my shop, my business in Lansing.
Was?
Yeah, I closed it to go back to grad school. This is a picture nobody's ever seen before outside of a few people. This is the audio test rig of a guy in Long Island, New York, that has worked fixing record lathe equipment since 1944. And he was also AES president at least once. Really neat guy, really nice. And these oscillators and voltmeters are instruments he designed as a consultant in New York in the 50s. I actually have one of these at the house, but really nice guy, really clever. And this rig in particular allows you to do frequency sweeps and drive square waves into record cutting heads to test them. This is also a crazy lab that nobody's seen a picture of before. This was a guy in Germany that I met, retired professor. He worked at Siemens before becoming an electrical engineering professor. So these are all Siemens, really rare secret company instruments mostly, and then some Rohde & Schwarz and Wendel and Goltermann and other companies. But you can see the German thing again, pretty complex. This is a test that he built just for testing cutter heads also. And so, really nice stuff. And his whole basement was sort of like this. So like, here's his listening room. Record lathe, tape machine, really nice broadcast vacuum tube monitors with electrostatic tweeters. A mixer he built, ViewMeter monitor amp he built, electronics for the lathe that he built, electronics for the tape machine that he built, electronics for monitoring feedback off the cutter head that he built, the cutter head that he built, the suspension. I don't know how he built as many things as he did in his basement. He's a pretty prolific guy. And this is something he said to me was very important. He has this cupboard full of transformers and tubes. So up here is all rare microphone tubes. And down here is all either materials for winding transformers for audio or actual audio transformers. And I think he spent 30 years collecting audio transformers.
So how much value is in that cabinet?
Priceless.
Yeah, basically priceless. There's stuff in there that nobody outside of the Deutsches Museum or German Post Office archive have. This was his manual lathe with a microscope, and he was building these parts. These are parts for repairing and assembling record cutting heads, which I'll show you at some later date. But these are just fixtures for putting them together. These are parts. These are parts for making parts. And these are parts, and yet more parts. So somehow this guy made these over a period of 2 years in his basement. And it's really crazy, but he did a beautiful job. So that's his hobby now. But so the point is, you start with, I want to take something apart, then I want to fix it, then I want to understand how it works. Then I want to make a better one. And that's where he'd gotten to. He'd already gotten past how to take them apart. He'd gotten past how to fix them. And he was engineering, you can see these numbers. He was testing different types of springs, different types of forms for coils, for the heads, different materials, different gap sizes for the magnets, different means of cooling the heads. So the way this works with design is taking things apart doesn't directly mean you learn how to design from taking things apart, but you learn your influences. So art students go to the art museum and then try to paint similar or learn other skills. Engineers can do sort of the same thing. You can take apart instruments and say, why did the engineer make these decisions? What problems was he trying to fix? What difficulties was he having or she having? So the same processes work, but it's you shouldn't put a gap in your mind between arts and engineering. It's the same apprenticed skill. You learn from people who are already good at it, you learn from doing it, you learn from taking apart the pieces of other people. So anyway, that's about it. And then this is a poster from Germany that I thought was hilarious. Because it was a grosser do contest. So anyway.